Hello friends, once again, welcome to my YouTube channel.
First of all, I thank you for taking your valuable time and interest in this laboratory based video. In this video, I'll show you the step-by-step procedures involved during the analysis of biochemical oxygen demand, or in short, the BOD analysis in any water samples by adopting the direct method of estimation. For your convenience and information, the content of this video revolves around the following. In the first stage, we'll have a brief introduction to biochemical oxygen demand, and then in second stage, we'll quickly see what are the different scientific estimation method used for analysis of BOD in any water samples. And in stage 3, we'll see the formula for calculation of BOD. And then in stage 4, I'll show you the step-by-step procedures for analysis of BOD in water samples, and last but not the least, calculation of the BOD using Microsoft Excel. So to begin with, stage 1, that is introduction to biochemical oxygen demand, or in short BOD. BOD is referred to as the amount of oxygen required by microorganisms to break down or to oxidize the organic matter present in the water samples. BOD is one of the major parameters used in most water quality study. By analyzing BOD, you'll be able to generate information about the level of organic pollution that a stream or a lake or a river is subjected to. After analysis of the BOD in any water samples, if you find that the BOD of the samples is very high, then that is a clear indication that the water is polluted. And if the BOD level in the samples analyzed is low, then it will indicate that the water quality is good. However, the level of BOD in samples differ depending upon the source or from where you've been collected. For example, a freshwater lake BOD level will be different from that of the polluted streams or from that of an industrial effluent. Next, in stage 2, we will see what are the different ways in which we can determine or analyze the BOD in any water samples. So for your information, there are 3 ways in which we can determine or estimate the BOD in any water samples. The first method is called the direct method, also sometimes referred to as the undiluted method. And the second method is called the dilution method, which is further subdivided into 2 types. One is called the dilution method with seed, and the other is called the dilution without seeds. However, in this video, I'll demonstrate to you the direct method of estimation of BOD in any water samples. Next, let's move on to stage 3, that is the formula for calculation of BOD in any water samples. And since we are adopting the direct method of estimation of BOD, the formula for direct method of estimation is as displayed on the screen. And the formula is BOD is equal to the DO level before incubation minus and the DO level after incubation. So the DO before incubation is referred to the dissolved oxygen content on the day the sample is collected from the field, and that's why DO before incubation is designated as DO0, whereas the DO after incubation is referred to the dissolved oxygen content after the samples has been incubated in an BOD incubator for 5 days. Therefore, in this case, it is designated as DO5. Next, let's move on to stage 4. That is the step-by-step
procedures for analysis of BOD in water samples. But before we proceed further, first of all, when it comes to BOD estimation in any water samples, if direct method of estimation is adopted, then the laboratory requirements and chemicals as well as the chemical reagents required are exactly the same like that of the dissolved oxygen method of estimation, adopting the azide modification of Winkler's methods. However, for BOD estimation, you'll need these additional requirement, and that is you'll need both the transparent BOD bottle, which we'll use for determining the dissolved oxygen content on the day of sample collection, and the brown BOD bottle, which will be used for determining the DO content of the samples after the incubation period. And for that, you will also need a BOD incubator. Similarly, even the chemical reagents required are also the same, and the different reagents will be used here are sodium thiosulfate solution, manganese sulfate solution, alkali azide iodide solution, starch solutions, and potassium dichromate solution. And if you want to see the detailed procedures of how to prepare these mentioned chemical reagent, then kindly check this video. And for your information, when you adopt a direct method of estimation of BOD in any water samples, you have to remember that there are two stages involved in the procedures. Stage number one is the analysis or the estimation of the dissolved oxygen right on the day the sample is collected. That is, once the sample is collected from the field, and when you reach the lab, immediately you have to analyze and find out what's the DO content of the samples collected. And stage 2 is the stage where you have to estimate the dissolved oxygen present in the water samples after 5 days of incubations in BOD incubator. For easy understanding, let us assume that these are the samples collected from this lake and we are interested in determining the BOD content of the lake. So to get this information, water samples are collected in two sets. In first set with 3 replicates, we'll use transparent BOD bottle, and the second set also in triplicates, we'll use the brown BOD bottles. The transparent BOD bottle will be used for determining the dissolved oxygen present on the day that the sample is collected, whereas the brown BOD bottles are meant for finding what is the dissolved oxygen content after the sample has been incubated for 5 days inside a BOD incubator. Now let's assume that the samples from the field have been transported into the lab. So first of all, when you reach a lab, take these brown BOD bottles filled with water samples to be analyzed and place them inside an BOD incubator for 5 days at 20 degrees Celsius. Then the next stage is you can start analyzing the dissolved oxygens present in the transparent BOD bottles. And to do so, the step-by-step procedures involved are as follows. Take the sample filled DO bottles and make sure that each samples in triplicates are given a code, because to avoid confusion in case you have a lot of samples to analyze. And the first step is the fixation of dissolved oxygens in the water samples. And to do so, first thing first is to each add 1 ml of manganese sulfate solution. Mix the solution by inverting the DO bottles repeatedly. And next, to each DO bottles, add 1 ml of alkali iodide azide solution. And on addition of this solution, a brown precipitate will develop. Mix the solution by inverting repeatedly and let the precipitate that is being formed settle down at the bottom. You can see that the precipitate settle down at the bottom. Next, to each DO bottles, add 1 ml of concentrated sulfuric acid. After mixing thoroughly, you'll see that the precipitate start to dissolve. After this, then the dissolved oxygen in the samples is fixed. So once your DO has been fixed, then the next step is the titration of the water samples. Before titration, first pour 100 ml of samples into a 100 ml measuring cylinder. Then transfer the measured samples into a 250 ml conical flask. And then to each samples add few drops of starch indicator. Stir the solution and you'll see that the solution turns blue or dark blue in color. Next, fill the burette with the sodium thiosulfate solution. There are two possibilities when it comes to sodium thiosulfate solution. Number one is when the sodium thiosulfate solution is prepared and is used directly for titration, then the normality of the prepared sodium thiosulfate solution can be given as 0.025 normality, whereas and possibility number two is after the sodium thiosulfate solution is prepared, then it is standardized against potassium dichromate. And through this standardization, you'll be able to find out the exact normality of the sodium thiosulfate solution prepared. And whatever value that you will obtain, then that value will be used as the normality of the sodium thiosulfate solution, and it will be used later on in the calculation stage. Next, let us now titrate the samples in the conical flask with sodium thiosulfate solution. Titrate the solution till the endpoint is colorless. Note down the initial and final burette reading to know the exact volume of sodium thiosulfate required to titrate the solution. And repeat the same procedures for the other replicates and also for the rest of the other samples. Let the burette reading obtained from the titration be as given below. This reading is the DO reading of the samples which has been analyzed immediately after this sample has been collected. For information, this data will be used later on in the calculation stage. Next, Let's move on to the next stage, which is the estimation of the dissolved oxygen after the samples has been incubated for 5 days inside the BOD incubator. To start this stage, first take out the BOD bottles and then proceed the analysis by first fixing the dissolved oxygen present inside the BOD bottle. And to do so, first to each BOD bottles add 1 ml of manganese sulfate solution. After adding, mix the solution by inverting the BOD bottles repeatedly. Then, this is followed by the addition of 1 ml of alkali iodide azide solution. And after addition of this solution, precipitate is being formed. Then you can let the solution stand till the precipitate settles at the bottom of the bottle. Then to each BOD bottles you can add 1 ml of concentrated sulfuric acid. Invert the BOD bottles till the precipitate dissolve, and after this the DO present inside the BOD is fixed. After completion of this stage, we'll move on to the next part, which is the titration of the samples which has been incubated for 5 days, or DO5. Before titration, first pour 100 ml of samples into a 100 ml measuring cylinder. Then transfer the measured samples into a 250 ml conical flask. Repeat the same procedure for the other samples. After doing this for all the different replicates of the samples, then to each replicate add a few drops of starch indicator. And after addition of starch indicator, you see that the solution turns blue or dark blue in color. Next, let us now titrate the samples with sodium thiosulfate solution. Titrate the solution till the endpoint is colorless. Note down the burette reading before and after each titration, and this will give us an information about the exact volume of sodium thiosulfate used, and repeat the same procedure for the other remaining samples or replicates. And let's assume that the data obtained from the titration is as displayed on the screen, and shortly this data will be used in the calculation stage. Next, let's move on to the next part, which is the calculation of the biochemical oxygen demand in the water samples using Microsoft Excel. So to do so, first open your Microsoft Excel sheet, and for calculation of BOD, for your information, you should know that dissolved oxygen formula is the backbone of the BOD calculation. So to begin with, for the calculation of biochemical oxygen demand, the first thing first we need to know clearly about is the formula. So let's bring the formula into this sheet. So this is the formula for BOD, where
BOD is equal to DO before incubation minus DO after incubation. And as already explained earlier, the DO before incubation is the dissolved oxygen content of the samples which was analyzed immediately after the samples has been collected, and DO after incubation is the DO content of the samples after the samples has been incubated for 5 days in an BOD incubator. Based on this formula, we can see that for acquiring the desired information, dissolved oxygen content before and after incubation is required. So for that, we have to incorporate the dissolved oxygen formula. So let us bring the dissolved oxygen formula into this sheet. And dissolved oxygen is equal to ml of the titrant into normality of sodium thiosulfate into 8 into 1000 divided by V within bracket V1 minus V divided by V1. So the first thing first we'll do is let's calculate the denominator. So we already know that V1 is the volume of the DO bottles, which is the capacity of the DO bottle used for collection of samples, and we use it at 300 ml capacity DO bottles. So the value for V1 will be 300. Okay, and V2 is the volume of the samples that is being analyzed. So that is V2 will be equal to 100. So V will be the volume of magnesium sulfate and alkali azide iodide solution used, which is 1 ml each, right? We have used. So 1 plus 1 is equal to 2 ml. So with that, we'll calculate the denominator now. V2 is 100, right? So V2 100 within bracket V1 is 300 minus V is 2 divided by V1 is 300. So if I do this calculation for this, I'll do the calculation first for the numerator. So is equal to 100 into 300 minus 2 will be 298, right? 298. So it will be equal to this much. So the denominator is 300 V1. Just keep it V1 is 300. So now the value for this will be numerator divided by denominator. So the value that you'll get is 99.33, which is the denominator for the formula, because this will be the same for all the samples. So that's why it's convenient to better calculate the denominator first. So now once you completed with this, next let's see the numerator component of the dissolved oxygen formula, and it is the ml of the titrant. So ml of the titrant will be the burette reading, and normality of sodium thiosulfate will be depending whether you standardize the sodium thiosulfate or you did not. So in case you standardize the sodium thiosulfate, because I did standardize the sodium thiosulfate, so the value that I'll use will be this 0.0269. But in case if you do not standardize your sodium thiosulfate solution, then you can use this value as 0. For this, you can keep the value as 0.025. Next, let us calculate the dissolved oxygen content of the samples the day it was collected. So we have a samples A1, A2 and A3. Let's assume that these are the burette reading of the replicate 1 from 0 to 4.3, 4.3 to 8.6 for replicate 2, 8.6 to 12.8 is for replicate 3. So these are the burette readings. So from the burette reading, we'll find out the volume of sodium thiosulfate consumed. So we just have to do is put an equal sign, final burette reading minus the initial burette reading. So this will give you the value, which is the volume of sodium thiosulfate to titrate the solution from dark blue or blue color to colorless. So this is the value that we obtain. From here, we can calculate the numerator values. ml of the titrant. So ml of the titrant is V. So V equal to V will be 4.3 into normality of sodium thiosulfate. Since I standardized my sodium thiosulfate, so the value will be 0.0265 into 8 into 1000. So this will give you the numerator portion of the DO formula. So similarly for the other replicates. Then the denominator is 99.33. So here also 99.33, 99.33. That's why I told you to calculate the denominator, because it will be the same for all samples. So from here we can find out the dissolved oxygen content of this sample the day it was collected. So it's very simple now. DO is equal to numerator divided by denominator. So this will give you a value of 9.18, and for A2 and A3 will be 9.18 again and 8.96. So these are the dissolved oxygen content of the samples the day it was collected. So DO0 value are these. Next, let us find out the dissolved oxygen content of these samples after 5 days of incubation. So the same samples we have collected from the same lake, right? Let's say these are the burette reading obtained. For A1, the initial burette reading is 0 and final burette reading is 3.1. And similarly, for A2 from 3.1 to 5.9, 5.9 to 8.8 for A3. So from here we can find out the volume of sodium thiosulfate consumed. So we just have to put an equal sign, final burette reading minus initial burette reading. So this will give you a value of 3.1. So similarly for A2 and A3. So this is the volume for all the three replicates. And now let's calculate the numerator part of the formula, which is equal to 3.1 into 0.0269 into 8 into 1000. And in the same way, just have to drag for replicates 2 and 3. And denominator is 99.33, 99.33, 99.33. So now finally we can calculate the dissolved oxygen of the samples after 5 days of incubation. So we just have to put equal sign, numerator divided by denominator, and this will give you 6.99 for replicate A and 6.04 for replicate 2 and 6.26 for replicate 3. Now using these data we will find out the biochemical oxygen demand of all samples collected. So we'll bring the dissolved oxygen content for the sample the day the samples was analyzed and paste it here. And then the dissolved oxygen content after 5 days of incubation and paste it here. Now the formula for BOD calculation is DO before incubation, which is this value, minus DO after incubation, which are these value. From there, the BOD value for the samples we analyze are collected is 9.18 minus 6.69. And similarly, just have to drag. So the value you'll obtain are these. So the mean value now, which is the most important value that you need to find out, will be 2.77. So the mean BOD value for the samples we collected and analyzed is 2.77. So with this, we can conclude that the BOD content of the water samples collected from the lake is very low, indicating that the water has minimal organic pollution. So this is the step-by-step procedures for calculation of biochemical oxygen demand in any water samples. So with this, we have come to an end of this video. And for your information, this video is based on the procedures prescribed in the standard prescribed book for water analysis. And the reference are mighty, and alpha. With that, we have come to an end of this video, and I hope this video will benefit and guide students who need assistance in understanding the method of analysis of biochemical oxygen demand in any water samples. So with that, if you find this video helpful, I humbly request you to kindly like, share, and subscribe to my channel. Your support is and will always be appreciated. Thank you so much once again, and God bless.